We know when two segments are equal, when they have the same measure. We know when two angles are equal, when they have the same angle measure. Today, when are two polygons, two shapes congruent to each other? Congruent. Here you go. Here's basically the definition of two polygons that are congruent. Guys, they have the same shape and they have the same size. Same shape, same size. And if you look at these two quadrilaterals I've given you, I'm telling you that they are congruent to each other. Okay, they are congruent. What's that mean? They have the same shape, same size. But I want to go beyond that now. When they're congruent to each other, they're ready for this new term, corresponding parts. Where have we heard that word corresponding before? One and 5, 4 and 8 are corresponding, right? We took these four, slid them down, and said, all right, which ones matched up with each other? Matched up. So here's what I want you to do right now for me. Do the same thing on these two quadrilaterals. Match them up for me. Take A, B, C, D, flip it over, put it right onto X, Y, Z, W for me in your mind right now. And what I'm going to do, the first person I'm going to ask today is, give me a pair of sides that match up. Okay, give me a pair of sides that would match up. Just one pair. 9. Here we go. One pair of sides that match up. Say that again. Sides, not angles. You can't give me a side with 1 point, right? Come on, sides. AB and side WZ. Everyone agrees those match up? Yes, they match up. And, ready? Because I told you the figures were congruent, so are these corresponding parts. If the figures are congruent, so are the corresponding parts. I'm not done. Let's go. Give me another pair of sides that match up, that correspond with each other. 8.
CB and XW.
Yep. Side CB and XW, meaning they are also congruent because the figures are congruent. Keep rolling. One more pair, and I'll take care of the final one. 2.
XY.
Got it already. Relax.
CD. XY, CD.
Why did I write XY there? Hold on. CD and XY. It's CB and XW. Relax. There you go. We're good. Back to business, and then let's see what's the missing one. I got AB. I got CB. What am I missing? AD. Yep. AD would correspond and be congruent to AD and ZY. All right, good. So the sides that match up are congruent. So do the angles. The angles. So now give me a pair of angles that match up and also would be congruent. Just use one letter, please. Just use one letter here. What do you got for me? 9. Pair of angles that match up. A and W, you sure? Because remember, I got to flip this over, right? A and Z. So angle A would be congruent to, that's awful, congruent sign, would be congruent to angle Z. Give me more angles that would match up and be congruent to each other. 1.
D and Y.
D congruent to Y. Here we go. Next up, what do we got? 11. 12.
X congruent to C.
X and C. Yep, good work. And then finally, what am I missing? B and W. Okay. If the figures are congruent, so are their corresponding. I'm going to call them parts. And what I mean by parts are sides and angles. Okay? Parts, sides, and angles. All right, I have a secret though. I was calling on all those numbers and you guys were telling me the sides and the angles. I never looked at the diagram to see if you were right or wrong, but I knew you were right. And not because I memorized the notes or anything like that, or I've done this 20 times already. I knew you were correct without even looking at the diagram. What was my secret? This statement, this given I gave you. This is called a congruence statement. Congruence statement. How did I use that to figure out if you guys were right or wrong? Somebody tell me, what's the first letter in the first quadrilateral it gave me? First letter in the first quadrilateral? A. What's the first letter in the second quadrilateral? Z. They're congruent. What are the first two letters in the first quadrilateral? AB. In the second one? ZW. They match up. So when you're given a congruent statement, they match up on the corresponding sides and angles match up. Does everyone see what I'm talking about? How you can use that statement to see what sides and angles match up? I don't need a diagram. I'm going to have you guys write one of these in a couple minutes. And when you write one for me, you're going to say this is congruent to this. All the sides and angles should match up on your statement. Good? Questions? Oh, this is why this day makes me so happy, because guess what is back? There they are. Statements, reasons. Couple days off. It's back. Anybody celebrate with me? Celebrate. Celebrate. All right. Couple celebrations. Yep. Yep.
God, I hate when he does this. It's the first period.
Okay, before you mark your diagram, decide if these triangles are congruent. How are we going to do that? If all the sides and all the angles are congruent. That's what we need to prove right now. If the triangles are going to be congruent, all three sides and all three pairs of angles need to be congruent. That's your job we need to help each other out with. So let's see what we have first. B and D are right angles. Mark them on the diagram. B is a right angle. D is a right angle. What else do we have here? AB congruent to ED. We put hash marks if you remember. Next up, BC congruent to CD. And finally, AC congruent to CE. The triangles will be congruent if all the sides and all the angles are equal. Good? So, I have all the sides equal. Everyone agree? All the sides are equal. What we need to do together is get all three pairs of angles together, or congruent. Get all three pairs of angles congruent. I did not write any. Do you know any pairs of angles up here that are congruent already? Let's talk. 13. Any angles up here you know are congruent? B and D. Why? There you go. Ready? Statement number 2. Angle B is congruent to angle D. I'm not making up any new reasons. These are reasons that were up on that board, second unit. All right angles congruent. Good, Charlie. I'm not making up new reasons. One pair down. Can anybody see another pair in that diagram that have to be congruent? And use something we've used already. Don't make up your own stuff. Anybody see any other pairs of angles in those two triangles that have to be congruent? Go ahead, Charlie. Okay, all right, never mind. We're good. Rachel, don't tell me why, just tell me the angles.
ECA and ECD.
These two are congruent. We'll talk in a second why, but let's write it down. Angle BCA congruent to angle ECD. Correct. Come on, we got to notice these now. We got to notice these right away. What type of angles did Rachel just give us? 12? Oh, go ahead. Actually, you know what? You already know. Why am I calling? We're not calling it. 10? There you go. So we say vertical angles are congruent. So we're almost there. I have all three pairs of sides and I have two pairs of angles. The only thing I have left is why is angle A and angle E congruent? And you're not going to know that. That's something new I got to teach you today. How many degrees are in every triangle? 180, right? 180. Look at what you already have. These two angles are congruent and these two are congruent. Don't write this down, but I want to show you using actual numbers here. We already know these are 90, right? And let me just say the vertical, I don't know, I'm just guessing. Vertical angles are 40. How many degrees are left for angle? I got 90 and 40, which add up to 130. How many are left for angle A? How many are left for angle E? So what we're basically saying is, if two pairs of angles in two triangles are congruent, what do we know about the third pair? They have to be congruent. And that is what's called at the bottom of your page, the third angles theorem. All right, which we'll talk about right now and write down. Here you go. In two triangles, if two pairs of angles are congruent, then what else do I know? If two pair are already congruent, then the third pair are congruent. Third angles theorem. But you got to have the first two pair congruent before you say the last pair. So here you go. Now we can go back to our diagram and finally say angle A congruent to angle E. Third angles theorem. I'm not, back in the day when I was rough and tough, before I became soft, I'd have people actually write out what we just wrote in the text box there. But do we have all three pairs of sides equal? Yes, no? Do we have all three pairs of angles equal? Okay, we got everything. Now I could say the triangles are congruent. So now we're going to write our own statement. Triangle. Name the first triangle any way you want. Your call. 7. Name one of those triangles any way you want. Triangle.
BCA.
Sure. BCA. Could have named it anyhow. But now order matters in the second one, right? Order matters. Congruent to triangle. I need to make sure B matches up with whatever angle it's equal to. A matches up with whatever angle it's equal to. So there's a certain way I need to write the second triangle here. So triangle BCA, congruent to, make sure all the sides and angles match up when you write this. 9, BCA and DCE. Looks good to me. And here's our reason. Definition of congruent polygons. Basically saying if all three pairs of sides are equal and the angles are equal, the triangles are congruent. So there it is. There's the proofs we're going to do today. Prove all three sides and angles somehow. Any issues, questions? You guys just want to get after it? The next proof? You're hungry? Oh boy, look who came up there, huh? Why do I even bother doing this? There's zero excitement. C congruent to D. And all right, a little review. Anybody remind me of this symbol? Perpendicular. So what should I be putting on my diagram? Right angles where those two segments meet. Remember, that's in your diagram. It is not in your proof yet. Keep in mind there. All right. Common mistake is diagram looks beautiful, but it never gets into your statements and reasons. All right, so it looks like I have two pairs of sides, right? But I need all three pair. And I hate to break it to everyone. I laugh when I say this, but there's no such thing as the third side theorem. All right, third angle theorem, and that's it. It's not because two sides are equal, the third side is. No, sorry. There's no such thing as the third side theorem. But let's take triangle CNG. What's the only side we haven't mentioned? We haven't mentioned side what yet? We have these two right now, but the only side I didn't mention in this triangle was what? Side GN. And in the other triangle, GND. What's the only side I haven't mentioned? Look at your givens. What's the only side that wasn't mentioned congruent in this triangle? Also. So you're saying both. The third side here is a shared side, GN. What do I know about GN and GN? Congruent by what property that you thought you'd never use, and I'm going crazy? Reflexive. So now you have all three pairs of sides. All right, let's go angles now. The only pair of angles I have congruent are C and D. I need other pairs of angles congruent. Name another pair of angles you already know are congruent up here. 8. We marked them, but we never said anything about them.
It's GNC and GNT.
The right angles, right? But here, whoa, whoa, whoa. Not in step 3. Anybody know why we're not going to say they're congruent in step 3? I still need to do what, Spence? You got to tell me the right angles first, right? Hey, I didn't do that in the last proof because it was given to me. I didn't need to write it down. It was given. But if you were going to tell me right angles are congruent, you have to tell me the right angles first. So angle GNC and angle GND are right angles. You have to state that they're right angles before you tell me they're congruent. How about a reason? Oh, I'll get back there. Yeah, perpendicular lines. If anybody uses definition of perpendicular, that's fine too. Now you can tell me they're congruent. It's always a two-step process. Always a two-step process. Tell me their right angles and then tell me they're congruent. So angle GNC congruent to angle GND. All right angles congruent. And then I have two pairs of angles now, the givens and the right angles. How can I get that third pair equal? Third angles theorem, right? Nothing fancy. I'm going to get these two angles up. Take a look. These two angles up here are going to be congruent because I have the other two pair already equal. So that's third angles theorem again. Angle CGN congruent to angle DGN, third angles theorem. And then now I have all 6 pairs of sides and angles. You can tell me the triangles are congruent. Questions? Again, please never use third sides theorem. Never will be a thing. Little fade. And then we got one more. Yep, one more question. All right, write a congruent statement for these congruent triangles. Before we do, before we do that, I want to have a little argument here. I don't know if those triangles are congruent or not. Are all the sides equal? All the sides congruent? Marked congruent? Yeah, they are. Okay. But I didn't mark all the angles congruent. I didn't put anything on H and R. Do I need to, though? Hey, do I need to put anything on there? We already know they're congruent by what? Third angles theorem. Okay, so just because H and R aren't marked, they're still congruent by the third angles theorem. So go ahead right now. You're going to come up with your own triangle so-and-so, congruent to triangle, and the angles inside should match up. So name the first triangle any way you want, remember. Name the first triangle any way you want. second triangle, the sides and angles should match up. Do not change yours when I ask somebody. Do not change, because there's different varieties we could have had that would have been correct. 4, here you go. What'd you start out with? Triangle?
DFH.
Okay, DFH, and you made that congruent to?
PZR.
All right, let me just check here. D and P. Oh, hold on here. Look at D and P. See how they're the first two letters? But if I look here, D and P, not congruent to each other, right? Change that second triangle again. The angles and sides have to match up. So you can keep DFH, but then it's got to be? That looks a little bit better. Z, P, R. Let's see, PR and FH. Yep, we're good now. Everyone else all right? How to match them up? I know I'm laying it on thick, huh? What do I got there? 4 problems tonight? 3? 4? Ooh, laying on thick. All right, go ahead. Get started.